Bismillahirrahmanirrahim. Dear students, in last lecture we completed the chapter number 7. We completed the chapter number 7 equilibrium according to the reduced syllabus. Now here we are going to start chapter number 8, acids, bases and salts. Acid, bases and salts. We are going to start this chapter. So in the acids, bases and salts, you have Bronsted-Lowry concept for acids and bases. Bronsted-Lowry concept for acids and bases there. So, according to the Bronsted-Lowry concept for acids and bases, Bronsted-Lowry concept for acids and bases. The acids are sour taste, strong acids are highly corrosive, and they change blue atmosphere to red. Bases are bitter in their taste, and they turn red to blue, and also strong alkalis, they are corrosive in nature. So that's why this is the introduction. There are three concepts you done in the matrix. Arrhenius concept for acid and bases. Arrhenius acid is a proton when hydrogen ion is going to be produced in the aqueous solution, and the hydroxyl ion is going to be produced in the aqueous solution. So these are called acids and bases. For the Lowry and Bronsted concept for acid and bases, an acid is proton donor. An acid is a proton donor. This is a Bronsted acid. Acid is a proton donor which is going to be donate proton, and base is a proton acceptor. So here, water is a base, it is going to be accept proton to give a hydroxynium ion and chloride ions, like this one. So from here you can see that water has two hydrogen atom and changes into three hydrogen atoms. Hydrogen is added, proton is added. So when proton is added, then it is called a Bronsted base. And there is a HCl hydrochloric acid. So you can see on the product side, there is a chloride ion. So hydrogen is no more, so it is going to be donate protons. That's why it is a proton donor. There is one thing more I am going to explain you. There is a conjugate acid and conjugate base. Conjugate acid and conjugate base. This hydronium ion positive charge is called conjugate acid, and this negative one is a conjugate base. The definition of conjugate acid is Bronsted base. Definition: Bronsted base when accept proton, the resulting species on the product side is called conjugate acid. For the conjugate base, the Bronsted acid when donates proton, the resulting species is called conjugate base. Mostly it has a negative charge, Bronsted bases, and Bronsted acid mostly they have a positive charge. And there is one thing is that hydrochloric acid, this hydrochloric acid, Bronsted acid, is a strong acid. Strong acids always have weak conjugate base. Strong Bronsted acids have always weak conjugate bases. So this is one thing. Second thing that water is an amphoteric. According to the Bronsted-Lowry concept for acids and bases, water is a amphoteric which can accept proton and which can also donate proton. So this is the base which is going to be accept proton when you are reacting with ammonia. Here. So this water is going to be act as a Bronsted acid. Because ammonia has more ability to accept proton. It has more tendency to accept proton. That is why ammonia acts as a Bronsted base and water acts as a Bronsted acid. Bronsted acid and Bronsted base. Okay, so when the one proton is donated by the water towards the ammonia, it forms ammonium ion. This is the ammonium ion in aqueous solution. So Bronsted base when accept proton, the resulting species is called conjugate acid. So ammonium is a conjugate acid of Bronsted base of ammonia. Ammonium is a conjugate acid for the Bronsted base of ammonia. And hydrogen is removed from the water. So you are getting the hydroxyl ions. So this is called conjugate base. The same definition is that when the Bronsted acid gives proton to the Bronsted base, the resulting species is called a conjugate base. Ammonia is a weak Bronsted base. Ammonia is a weak Bronsted base, so its conjugate, this water is a weak Bronsted acid, so its conjugate base is a strong. Water is a weak Bronsted acid, so its conjugate base is a strong. Hydrochloric acid is a strong bronze-state acid, so its conjugate base was weak. Strong acids have always weak conjugate base, and weak acids always have a strong conjugate base. So in this case, water acts as a bronze-state acid and bronze-state base, bronze-state base, bronze-state acid. So it is an amphoteric. So water acts as an amphoteric. It is an amphoteric compound. There is another one. I am going to explain this one. You have acetic acid. Acetic acid is a bronze-state acid, but it is a weak acid. Acetic acid is a bronze-state acid, but it is a weak acid, donates proton towards the water to give a hydronium ion and acetate. This is an acetate ion. So water is a bronze-state base. When the hydrogen is added to give a hydroxynium ion, so this is called a conjugate acid of bronze-state base. Acetic acid is a bronze-state acid, weak acid. When hydrogen is removed, the resulting species negative acetate is called conjugate base. The bronze-state acid is a weak. Bronze-state acid is a weak, so its conjugate base is a strong. Conjugate base is a strong. Dear students, acetic acid also act as an amphoteric. Like this one. Hydrochloric acid is a very strong acid. Its pK values are very, very low indeed. It is a very strong acid. So acetic acid is a weak acid, so must be it accepts proton from the HCl. So this HCl is a bronze-state acid. Acetic acid is a bronze-state base. Same equation you will do in the leveling effect. So this is the bronze-state acid and this is the bronze-state base. So what you will get, CH3COOH2 plus. So this is a conjugate acid, and chloride is a conjugate base. And strong acids always have a weak conjugate base. So students, acetic acid here acts as an acid, acetic acid here acts as a base. So it is and also it is also amphoteric. both properties shown by the acetic acid. That's why it is also acts as a acid as well as base. So these are the Bronsted acids and Bronsted bases. And also I told you about this whole. Students, basic conjugate acid and conjugate base, I told you the definition. Again I am telling you, conjugate acid species which is formed as a result of acceptance of proton by the base. Acceptance of proton. This is the base. When it accepts proton, the resultant is called conjugate acid. And the acid is when the Bronsted acid donates proton, the resultant species is called a conjugate base. Conjugate base is species which left behind after donation of proton from the acid. So this reaction I told you about this one. Yes. Now there is one thing. Acid base pair. Let this example. Acid base pair. Acid base pair. Acetic acid is a Bronsted acid. So it forms conjugate base. Acetic acid is a Bronsted acid and it forms a conjugate base. Water is a Bronsted base, it forms conjugate acid. Now, Bronsted acid is denoted by A1. Bronsted acid is denoted by A1. Bronsted base is denoted by B2. A1 is the Bronsted acid and water Bronsted base is a B2. Then conjugate acid is a A2. Conjugate acid is a A2. Conjugate base is a B1. Like this. So when you are going to make a acid base pair, then conjugate this Bronsted acid A1 with the conjugate base B1 and Bronsted base with the conjugate acid A2 is called acid base pairs. So I am writing another equation. Ammonia plus water. Ammonia is a Bronsted base and water is Bronsted acid. So Bronsted base is a B2. Bronsted acid is a A1. Then this is going to be donate proton to make ammonium ion. This is the ammonium ion. And this is the acid. It's called Bronsted conjugate acid A2 plus this hydrogen is gone from the ammonia to make OH, and this is called B1. Now for the acid base pairs, this is the Bronsted acid B2 must be B1, must be B1, A1 to B1 and B2 to A2. So B2 to A2. Like this one. Bronsted base 2. This is the conjugate acid A2. Then there is the Bronsted acid A1 with the conjugate base B1. This is called acid base pairs. Acid base pairs. A1 with the B1 and B2 with the A2. These are called acid base pairs. So, dear students, there is the identification of conjugate acid base pairs. I told you conjugate acid base pairs. This is the acid base pair, and this is another acid base pair, B2 to A2 and A1 with the B1. So you have here many examples for this one. So I'm going to write two from here, only two from this one. I'm going to write here A1 plus B2 and then B1 plus A2. Now examples different I'm writing here. Suppose water H2O plus carbonate. Look here. So this is a proton donor. A1 is a Bronsted acid. Carbonate is a Bronsted base because this water when donated it give a conjugate base B1 and plus hydrogen is added to give a bicarbonate here. So this is a conjugate acid. So A1 is Bronsted acid and B2 is Bronsted base. B1 is a conjugate base. A2 is a conjugate acid. So when you make a pair, A1 means Bronsted acid to the conjugate base, and B2 Bronsted base with the conjugate acid. This is one example of the Bronsted conjugate acid base pairs. So there are many you have to solve. There are many here. I'm going to write only one or two. So this is the one. I'm writing another one also. Very strong acid. Strongest acid, perchloric acid. Perchloric acid. This is the Bronsted acid. Bronsted acid. Water is a Bronsted base. Bronsted acid, Bronsted base. To give conjugate base, perchlorate. Perchlorate is a conjugate base, and hydronium ion is a conjugate acid. So this is the perchlorate, very strong acid. Bronsted acids, strong acids always give weak conjugate base. So this is the A1 Bronsted acid, A1, B2 Bronsted base, and this is the B1 conjugate base. A2 is a conjugate acid. So acid base pairs, this is the conjugate acid with the Bronsted acid with the conjugate base, and Bronsted base with the conjugate acid. Acid base pairs. These are called acid base pairs. A1, B2, B1, A2 are called acid base pairs. Conjugate acid base pairs, major concept I told you, identification I told you. Now, students, strength of acids and bases. Strength of acids and bases according to Bronsted-Lowry concept for acids and bases. We know that according to the Bronsted-Lowry base, acid is a donor of proton and base is an acceptor of proton, means hydrogen ion. So when we are talking about the strength, means how much acid is strong and how much acid is weak. So definition of the strength of acid means strong acid, an acid which can donate proton to a higher degree than other acid. The acid which has ability to donate proton with a high degree than other acid is called strong acid. It has a more strength. That acid has a more strength. Repeating again, an acid which has high ability, more ability to donate proton than other acid is called strong acid. It is to be a relatively strong acid as compared to the other. Hydrochloric acid is a strong acid as compared to the acetic acid. Already I given the examples for this one. Acetic acid relatively strong acid than water, both are done. Acetic acid as an amphoteric. Acetic acid in water, acetic acid as a Bronsted acid has a more ability to donate proton as compared to water. But when acetic acid with the hydrochloric acid, so hydrochloric acid is more ability to donate proton towards the acid. So the strength of acid depends upon how much the acid is going to be donate proton, ability of donation of proton. Similarly, base has the ability to accept proton. The base which is a high degree of acceptance proton from the acid as compared other base is called a strong base. Ammonia is a relatively stronger base than water. So when I've done the acid base pair, water is going to be donate proton towards the ammonia. So water is going to be donate base ammonia. Ammonia has ability to accept. So that's why ammonia is a stronger base and water is a weak base, because ammonia has great ability to accept proton, more strength about base. So that's why ammonia is a stronger base than that of water. So this is called strength of acids and bases. Conjugate acid and conjugate base, already I told you according to Lowry and Bronsted concept for acids and bases. Dear students, we are going to stop here. In the next topic, we will follow the reduced syllabus inshallah. So thank you very much.